Okay, now let's look at a problem given a table of values. So this gives the rate at which water is being pumped into a tank of a continuous and increasing function r of t. There's selected values for r of t. So this is saying at time 0, water is being pumped in at a rate of 7 gallons per minute. And then at time 4 minutes, water is being pumped in to a tank at a rate of 13 gallons per minute. So as you can see, these numbers are water is getting pumped in at a faster and faster rate, and it's saying the entire function is increasing. So even though we don't know what happens between, let's say, 4 and 6, the numbers are still getting bigger for that rate. Okay, so the first question says, let's use a right-hand Riemann sum. So this word Riemann sum is just another way to talk about the rectangles. So this is saying use a right endpoint rectangle. So that's all that means, this piece right here. And we're going to use 4 rectangles to approximate the area underneath the curve. So my first rectangle is going to go from 0 to 4. So let's take a quick picture of this. You don't have to plot this, but this is what's happening. If this is t, if this is r of t, 0, 7 would be your first point. Then you have 4, 13. Then you have 6, 18, etc. So my first rectangle is going to give me a width of 4. And the height, we're going to use the right y value is going to be this. So that would be the 13. And then your next rectangle is going to go from 4 to 6. So notice the width is 2. So the width does not have to be the same in a table. And we're going to use the right number, which this time is 18. So this pattern continues. So the next width is going to be 4. Then the height there is 23. The last rectangle is 3, and the height there is 27. So notice I have 1, 2, 3, 4 rectangles. And if you punch that out, you're going to get 261. So let's try to figure out what does this number represent. So let's think about units first. So this 4 was the time difference. So the units on this would be minutes. The 13 is your rate, so it would be gallons per minute. And all we're doing is adding a bunch of these. Notice the minutes cancel out. So really, the units on the 261 is gallons. So this is saying that 261 gallons of water are pumped into the tank from time 0 to 13 minutes. Okay. The next question is the approximation greater or less than? Well, we always have to go back to what we're given. They tell us this is an increasing function. So this function is increasing. So we learned, and if you just look at the picture, when we do a right hand, the rectangle always goes over. So we're going to say it's greater, but we always want to justify what's given. And they told us that this is an increasing function. So we're going to say because r of t is increasing. And then last thing with this problem is, what if I use midpoint rectangles? Now, when I give you a table, you cannot create any points on your own. You have to use the points that are given. So when I do a midpoint with the table, I'm actually going to be using less rectangles. So the only way to get a number in the middle is if I use these 3 data points as the width. So the width of the first rectangle is actually going to go from 0 to 6, but then I'm going to use 13 because that's the y value in the middle. So that's my first rectangle for a midpoint. The next one is going to go from 6 to 13, so the width there is 7, and the y value in the middle would be 23. So you're going to get 239 gallons using a midpoint. Okay. The second one here says, this is talking about the rate at which customers are being served at Starbucks. It's a continuous function. There's a table, and it also tells us that there are already 200 customers that have been served. But at time 0, when it starts, whatever that time is, there's 37 people per hour being served. Okay, so I want to use a trapezoidal sum with 4 trapezoids to approximate that exact area underneath this curve. Okay, remember the area of a trapezoid is 1/2 the height times the sum of the 2 bases. So my first trapezoid is going to go from here to here. So 1/2, the height is the width. And then those are my 2 bases. There's my first trapezoid. Second trapezoid is going to be 1/2 right? With this 1, your bases are 44 and 36. So the pattern continues. 1/2, 3, 36 plus 42, and the last one would be 1/2, 4, and then 42 plus 48. And I believe if you punch out these numbers, you're going to get 418 people, and that would be this area underneath the curve. Now look at the last question. It says, how many customers have been served after 10 hours? Okay, this 418 people are the number of customers who have been served from time 0 to time 10. But this said that there were 200 customers who had already been served before this had started. Remember, time 0 doesn't mean when it opens. It could be 10 a.m., whatever they said time 0 to. So if I want to know how many have been served after 10 hours, we would have to add that 200, so we get 618 people. So the important thing to notice is this is how many people have been served after 10 hours. This is how many people have been served during that 10-hour interval from 0 to 10 hours.